Hi all, myself Dr. K. Ashok, Associate Professor of Physics, Marri Reddy Institute of Technology and Management. Today I am going to discuss about the optical fibers, which was the 5th unit of Applied Physics of first BTech students. In the previous session, I discussed about the optical fiber and its principle. What is an optical fiber? Basically, optical fiber consists of three parts. The central part is called core. This is called core, and core is surrounded by a medium called clad, and clad is surrounded by a outer jacket. Outer jacket gives only mechanical protection. The refractive index of the core I will take it as N1, and the refractive index of the clad I will take it as N2. N1 is greater than N2. What is the meaning of it? Core is the denser medium, clad is the rarer medium. If you draw exactly center of the core a line, that is called axis of the fiber. In this, core and clad plays a vital role in transmitting the signal. This jacket has no significance. Here the fiber transmits the signal based on total internal reflection. What is the total internal reflection? Whenever light travels from denser medium to rarer medium and angle of incidence is greater than the critical angle, then total internal reflection takes place. So if you cut this optical fiber vertically with a plane, if you cut this one exactly with a vertical plane, then it looks like this shape. This is nothing but clad part. This is also clad part. See, if you come like in this format, if you observe, see, that is the scenario. So I am cutting vertically, so that what happened? Then it looks like this one. This central part is called what you know? Core. And this is the axis of the optical fiber. Now I am going to calculate the acceptance angle. What is the acceptance angle? The particular angle of incidence at the fiber at which this signal can propagate through the fiber with multiple total internal reflection. Every signal whatever we incident in front of the optical fiber cannot pass through the fiber. Only at a particular angle of incidence only the signal can reach the other end. That particular angle is called acceptance angle. Acceptance, in the name itself it is there. This is the particular angle where fiber accepts the signal. Now I am going to calculate the acceptance angle. This is completely derivation part. Already I showed you. So this is about the optical fiber vertical cross section. This is called clad, and this is also called clad. Clad refractive index is N2, clad refractive index is N1, and this is nothing but core, the central part, the refractive index is N1. Now exactly one axis will be there at the center of the fiber. This is called axis of the fiber. Let the fiber present in a medium, its refractive index is N0. Sometimes this fiber may present on the earth, some other times it may present in the oceans also, because entire globe is connected with these optical fibers under the oceans also. Now see here, I am incidenting a signal. This is called incident ray. Here this is like acts as a normal axis. This particular angle of incidence I will take it as incident angle. The incident ray is reflected. So here this is called alpha r. Refracted ray is called alpha r. First you observe, this is the point A. Point A is the incident light from outside the fiber. Now here I am drawing another normal. Then this is the incident ray for the point B. This angle of incidence, I will take it as theta I. Now, I will apply law of refraction. Law of refraction at A, at point A. What is the law of refraction here? Refractive index into sine of the incident angle times is equals to N1, because the ray is passing through core. Core refractive index is N1 and angle of refraction is called alpha R. Here I will mark this point as C. You can observe there, this point is A, this point is B, this point is C. Here this angle is nothing but alpha R, this angle is nothing but theta I, this angle is 90 degrees. By angle sum property, sum of the angles in a triangle is 180 degrees. That's why alpha R plus theta I plus 90 is 180 degrees. Alpha R plus theta I equals to 180 minus 90. Alpha R plus theta I equals to 90 degrees. Here what you have? Alpha R. Alpha R equals to 90 minus theta I. Now our equation becomes N0 sin alpha equals to N1 sin of 90 minus theta I. Now N0 sin alpha I equals to N1 into sin 90 minus theta I. Sin 90 minus theta I becomes cos theta I. Sin 90 minus theta I is cos theta I. Now here I am adjusting this alpha I to a particular angle called acceptance angle. Here you are adjusting incident angle to acceptance angle means here what happened, you know, the incident ray is more than the critical angle. Already I showed you, okay, how to find the critical angle here. Simple. At point B, I am applying law of refraction. Means the ray is moving from core to clad. N1 sin theta I equals to N2 sin theta R, usually law of refraction. But here this theta I am telling it to theta C. When theta I is reaching theta C, what is the theta R value? 90 degrees. N1 sin theta C equals to N2 sin 90 degrees. N1 sin theta C equals to N2. Sin theta C equals to N2 by N1. Here, if alpha I equals to alpha M, I told you theta I equals to theta C. Means here we are adjusting the angle outside the fiber so that here it is incidenting at an angle more than the critical angle. Means here total internal reflection is taking place. Now our equation becomes N0 sin alpha M equals to N1 cos theta C. We know sin theta C value. What is the relation between sin theta and cos theta? Sin square theta plus cos square theta is 1. That's way here you can write it as 1 minus sin square theta C. N1 under root of 1 minus N2 square by N1 square, because sin theta C is N2 by N1. Sin square theta means square it, N2 square minus N1 square. Now here this I will arrange. Now our equation becomes N0 sin alpha M equals to N1, you take LCM, N1 square minus N2 square, N1 square minus N2 square by N1, because after LCM I am bringing N2 square outside. That's why it becomes N1. This N1 and N1 will get cancelled. Sin alpha M equals to under root of n1 square minus n2 square by n0. Our target is to calculate acceptance angle. I showed you acceptance angle with alpha m. From here alpha m I need to calculate. What is alpha m? You know, sine inverse of under root of n1 square minus n square by n0. This is your acceptance angle. If you know the refractive index of the core and clad and the medium where the fiber present, then you can calculate the acceptance angle. If you rotate this acceptance angle about the fiber axis, what happened? It defines a cone. That cone is called acceptance cone. See, this is the acceptance angle. Okay, we are rotating this acceptance angle about the fiber axis. It defines a cone. This cone is called acceptance cone. Whatever the signal incident in this acceptance cone can pass through the fiber with multiple reflections, total internal reflections. If the signal is not falling in this acceptance cone, it will be lost. Simply it won't reach the other end. In this manner, the light ray is traveling from one end of the fiber to other end without any material medium. This is known as acceptance angle and acceptance cone. So these are the references I used for the making of this PPT. Thank you for watching.